Hi there. So we're going to go over 6.3 domain and range review today. So when comparing two quantities, the words domain and range are used to describe the values that are appropriate. And we talked about what domain was. It is the set of all possible values for the independent variable in a relation. And range is the set of all possible values for the dependent variable as an independent variable takes on all possible values of the domain. And we often denote domain using x as a variable and y for range. And we also discussed what set notations were. It's a formal mathematical way to give values of the domain and range. So we talked about how the notations work here. So when we want to represent what domain is, we write it in this form. The squiggly bracket is the type of brackets we use for sets. That alphabet E means is an element of, and that bar means such that, and the statement is read as follows. X is an element of real numbers such that x is less than or equal to 10. Same idea goes to range. We write it this way. All those notations mean the same thing here. And the statement is read as follows. Y is an element of the real numbers such that y is greater than 20. So that's it for the notation. Let's take a look at example 1, part A. Write the domain and range of this graph. So this filled in circle here, it is an inclusive point. Whereas this empty circle here means it is exclusive point. In order for us to write the domain and range, we need to understand what kind of value of x and y we have here. So let's take a look at the coordinates. So the x value for this point here is 0 and 6. Whereas this point, x value would be -4 and y value is -1. So we have two coordinates. It is important to know whether or not this point is inclusive or exclusive when we're writing a domain and range. I'll show you what I mean by that. So when we're starting domains by using set notation, we need to start with the squiggly bracket. You open the bracket. For domain, we always write in terms of x, and we write down the bar to indicate that we are only referring to x. We always start with the lower limit, which was, in this sense, x. All the possible value of x would be -4 to 0. So what we're going to do, we're going to say x is in between -4 and 0. But notice that this point here is inclusive. So we do have to add that extra bar there to make sure that this part indicates x is less than or equal to 0. And don't forget, we need to add x is an element of all real numbers and close the bracket here. Notice that this condition just means that x is greater than -4, but also x is less than or equal to 0. But we just combined it into one condition. Let's take a look at range now. Open the bracket. Y such that the lower limit for y this case is -1. It goes all the way up to y equals to 6. So y is in between -1 and 6. And notice that the second point, the upper limit, is inclusive, so we have to have another bar there to make it y less than or equal to 6. Don't forget, y is an element of all real numbers. So for part B, we just need to follow the exact same step for this. We know this is exclusive point and this is inclusive point. The coordinate of this exclusive point is -5 and 1, whereas this one, inclusive point, is 4 and -2. Domain is in terms of x, so x such that the lower limit of x is -5, and it goes all the way up to 4. So we're going to do x is in between -5 and 4, and inclusive on x equal to 4, where x is an element of all real numbers. For range, we're going to open the bracket again. Range is in terms of y, and the lower limit for y is -2, and the upper limit is +1. So we're going to write y is in between -2 and 1. Notice that it's inclusive at y equal to -2. Don't forget, y is an element of all real numbers. So that's it. Now let's take a look at example 2. State the domain and range of discrete graphs. So discrete graphs are graphs that are not connected, just like part A graph here. So let's take a look at how to write the domain and range for a discrete graph. Domain is always in terms of x, so we have to write down x in terms of, or such that. And notice that this point here, x value is -5. For this point here, x value is -4, and so on. So we can say that x such that x equals to -5, -4, and dot dot dot. And you do have to write down the upper limit, so 1, +1 right here. And we close a bracket. Another way to write the domain for this case would be using conditions. So x such that the lower limit of x was -5 and upper limit was 1. And they're both inclusive, so we do have to have the equal sign on both sides. Don't forget, x is an element of integer value because integer are the positive and negative whole numbers. So for range, we open the bracket, write y such that we know that y is starting at -6 here. This is -4, -2, 0, and so on. It goes up by 2. So let's do this. So -6, -4, and so on, continuing the pattern all the way up to 6. We're going to close a bracket. We cannot use a condition just like the previous one here. We cannot do this because y doesn't exist everywhere in between, even as an integer. Y doesn't equal to -5, and y doesn't equal to -3, and so on. So there's too many elements that's missing, so we cannot denote it this way. We're moving on to example 3, domain and range of continuous graphs. So domain of this graph is actually quite simple. We open the bracket and notice how all the values of x are defined on this line. Anywhere you pick, x will be valid. So we can say x such that x is an element of all real numbers, because domain, all values of x is valid. Same idea for range. Open the bracket, y such that y is an element of all real numbers. Same idea. Anywhere you pick, y value is defined. For part B, the domain in this case is a bit special. Notice that x value for this, and this is y, the x value here is 5. Is there any other x values we can choose other than 5? No, there isn't any. So we have to say x has to equal to 5, and 5 only. For y, though, notice y is defined everywhere. So we can say y is all real. We're on example 4, the last example of the day. We're going to look for domain and range of the graph with endpoints. So endpoint means that it's a point that ends the relation. This is not an endpoint because that is, first of all, not a point, it's an arrow, so it's continuing the pattern. So that empty circle we talked about before, it is called an exclusive point. So we know x does not equal to -4 and y doesn't equal to -2. So this coordinate is -4 and -2. So let's write down the domain. Open the bracket, x such that, notice that x value here is from this point and continually going to the right, to the positive side. So we can say that the lower limit for x is -4. X is greater than -4. We do not write less than infinity. We do not write this because set notation doesn't allow us to use infinity sign. So we put this way, so -4 is less than x, or actually better way is x is greater than -4 and x is all real. For range, y such that, notice our y here is going from here down here. Oops, from here down here. So we can say that y is less than -2. And it's exclusive, so we do not add the equal sign there. And y is an element of all real numbers. So that's it for today. So I'll see you guys in the next video.